1.
Okay, so I'm Melissa Robinson,
I'm Kayla Roble.
and we did 2 of Jupiter's main moons, which is I did Callisto.
And I did Ganymede.
Don't worry about those 2.
So this is Ganymede right here, and this is its orbit around Jupiter, which takes 7.2 Earth days, and it is the largest moon of Jupiter with a diameter of 3,273 miles, and it was discovered by Galileo on January 7th, 1610. And Ganymede is Greek for cupbearer of the gods. And Ganymede is about 665,000 miles away from Jupiter, so from here to here it is that distance. And it was one of the first 3 moons to be found orbiting a planet besides our own moon. And then it's Jupiter's largest moon out of Jupiter's other 79 moons, and it's the biggest moon in our own solar system. And Ganymede's actually larger than Pluto and Mercury, meaning if it orbited the sun, it could possibly be considered a planet. And it travels at 24,336 miles per hour. This is a picture of Ganymede that isn't an animation. And it has temperatures anywhere from negative 171 degrees Fahrenheit to negative 279 degrees Fahrenheit. It has an atmosphere made up of oxygen, but we can't live there because it's like strictly oxygen, whereas our Earth's atmosphere has other things like small traces of nitrogen and hydrogen. And then 100 pounds on Earth is equivalent to 14.48 pounds on Ganymede. And the surface age of Ganymede is actually about 4 billion years old, which is one of the oldest ones in our solar system. And Ganymede is made up of silicate rock and water ice.
And then here's just a size comparison between Ganymede, Callisto, and then our very own moon. So, I did Callisto, which was discovered by Galileo Galilei. He discovered most of the main moons for Jupiter. It's the 3rd largest moon in our solar system, but the 2nd largest moon for Jupiter's. It has orbital speed of 18,400 miles per hour, and it takes about 17 days to orbit. And then a little fun fact about Jupiter's moons: they didn't originally have like the names like Callisto, Ganymede, Io. They were called Jupiter 1, 2, like they were just numbered, but as they kept discovering more moons, they're like, okay, we have Jupiter like 923, this is going to be a little difficult. So they decided to give them names. And Callisto is one of the oldest, has one of the oldest surface ages of all the moons. It's estimated to be between 4 to 4.5 billion years old. It's pretty much the same composition of Ganymede. It's made out of rock and ice with some silicate, yes. It's composed of like 60% of like rock and iron for the rock, and then 40% ice. It has a very thin atmosphere. It's mostly CO2 and molecular oxygen, which is again not the same kind we breathe. There's carbon dioxide, nitrogen, all that stuff in our air. And its temperature, its average temperature is negative 218 degrees. And then 100 pounds on Callisto is, you're just under 13 pounds. Or 100 pounds on Earth, you're just under 13 pounds on Callisto. And then, a little fun fact about Callisto is it's not affected by the gravitational pull of Jupiter. It's actually really far away. Actually, I think it's on there. No. Oh yeah, that's the other side. Okay, so it's really, really far away from Jupiter. It's over 1 million miles away from Jupiter, pretty much. I'm not good enough with numbers to list every single one off. So it's not affected by its gravitational pull, but it is tidally locked with Jupiter, like our moon, so it's always facing it in one direction.
One of the main spacecrafts that has gone to see these moons is spacecraft Galileo, which was sent to view Jupiter and its moons on October 18th, 1989. It was sent on Shuttle Atlantis at the Kennedy Space Center, and Galileo found indications of saltwater layers under the surfaces of both Callisto and Ganymede. And the end of Galileo's journey was on September 21st, 2003. And Galileo was actually sent into Jupiter's atmosphere at 30 miles per second to end its journey. This burned up the spacecraft so it wouldn't disrupt the moon's current states, because if it were to hit one of the moons, it could possibly knock it out of orbit or damage it. So this is an animation of Galileo's trip. Galileo would be the pink line here. And it started at Earth and went around Venus, which is the green one, 2 times to catch up speed as to save fuel before launching to meet up with Jupiter and its moons. And this is an animation of the end of Galileo's journey. As you can see, it's orbiting Jupiter many, many times to gain enough speed to burn up in its atmosphere.
Any questions?
So you said molecular oxygen. How is that different from our oxygen?
I said our oxygen has extra elements in it, so we have a CO2, nitrogen. It's a whole mix of things to make air. Molecular oxygen is just O2.
Breathing pure oxygen is bad for you.
You'll die.
When you I just need to clarify, when you said it's not gravitationally influenced, it's gravitationally bound to Jupiter, but I think what we're saying is it doesn't keep the innards molten, like with Io. The reason Io is so molten is because it's so close to Jupiter, it's gravitationally getting pulled that way. It's close to 2 other moons, so Io's guts stay liquid because of those gravitational tugs, where Callisto is far enough away that that's not really what's happening with Callisto.
Anything else? Thank you.
So, what are we doing, Europa?
Titan and Enceladus.
Oh, okay. So one more moon of Jupiter.
And 2 moons of Saturn. Okay, so we've got an ensemble of moons for you. We have 2 moons of Saturn, Titan and Enceladus, and 1 moon of Jupiter, Europa. So mine is Titan. Titan's the largest, most massive moon in orbit around Saturn, and it's only one of 62 moons around Saturn. It was discovered in 1665 by Christian Huygens. He was inspired by Galileo's observations of Jupiter's moons just 45 years earlier. So these are the brothers and sisters of Cronus, the Greek version of Saturn, and the collective title for all of these people are the Titans. As you can imagine, it would make sense to call the first discovered moon of Saturn Titan. And another interesting tidbit is the fact that Huygens didn't even name Saturn, he just called it Saturn I. It wasn't officially named until a few hundred years later by John Herschel, who was the son of William Herschel. And here's kind of it ranked alongside other bodies in the solar system. It's larger than Mercury. Titan has a pretty quick orbit around Saturn, but it orbits over 750,000 miles away from the planet. It just takes 16 days. Despite being so far away, the orbital speed is a whopping 12,459 miles per hour, which equals about 3.5 miles per second. So Titan's pretty unique, is because it has an atmosphere. It's made up of 98% nitrogen and about 2% methane and other hydrocarbons. Titan's atmosphere is actually about 1.5 times heavier than Earth's. Titan's unique atmosphere and distance from the sun allows it to be the only other planet or moon we know that has stable bodies of liquid, surface liquid, or rain. The difference is that on Titan, the surface liquids and rain aren't made of water, but they're made of methane and ethane. On Earth, those molecules make up natural gas, but on Titan, where it's hundreds of degrees below zero, those molecules turn into liquids. That's just a comparison between Earth, Moon, and Titan. Despite its large size, as you can see, its gravity is pretty weak due to its low density. This is caused by the material that Titan is made out of. It's mainly made of ice and rock. Since Titan is far and away the largest moon orbiting Saturn, it doesn't really receive any tidal heating, but it does, or from any other moons, but it does get tidal heating from Saturn, which does cause cryovolcanism, which is like cold volcanoes made of water and ammonia. The surface of Titan is really young, constantly being resurfaced by winds and rain. This makes it one of the youngest surfaces in the solar system. The Huygens probe was sent to Titan along board the Cassini spacecraft and detached from Cassini in 2005. Here's one of the pictures it took as being sent to the surface. So here are a couple weird things about Titan.
Oh, this is a real picture.
No, this is not a real picture. It's an artist rendition. So a couple weird things. The atmosphere is so dense and the gravity is so low is that, so if you strapped on a pair of wings, you would fly on Titan. Titan has various lakes and seas. The largest one, Kraken Mare, is larger than Lake Superior in North America. So who needs a $3 million lake home on Minnetonka when you've got Titan?
All right, good evening everyone. Welcome back to our second night of Unveiling the Universe. My name is Joseph Klasowski, and I will be covering Europa. And I would like you to take note of these brown sort of probosces extending across the surface of Jupiter that'll come up later. All right, so Europa is the smallest of the 4 Galilean moons of Jupiter, and Jupiter has 79 moons in total. And they are called the Galilean moons because not only are they the 4th largest, but all 4 of them were discovered by Galileo Galilei. Alright, and as I said, it was first discovered in 1610 by Galileo, and it is named after Europa, who is a lover of Zeus and a mother of King Minos, who are, if you are familiar with Greek mythology, was the owner of the infamous labyrinth with the Minotaur. He is also the namesake for the Minoan civilization that resided on Crete. And as far as the story goes, Zeus is the white bull here, and Europa is the woman in pink on top of the bull. Alright, and here's a picture of Jupiter with its Galilean moons again. Europa is 414,000 miles from Jupiter. It has a diameter of 1,900 miles, and its temperatures range anywhere from -370 to -260 degrees Fahrenheit. However, the -370 degrees you'll only really find at the 2 poles, so they're relatively localized. -260 is a more general temperature for the rest of the planet. And 100 pounds on Earth is equivalent to about 13.35 pounds on Europa. And Europa does have an atmosphere, and it is composed entirely of oxygen. And that has to do with it has these water vapor plumes that shoot out into outer space. And what those do is they shoot out vapor composed of nitrogen and oxygen. However, the nitrogen escapes out and leaving only the oxygen behind. Alright, and so here we have a graph of its orbit. Europa is the middle one right here. And its orbital period lasts 3.6 Earth days. Its axis rotation is 3.6 Earth days. And it has an orbital speed of 30,825 miles per hour. And if you notice, its orbital period and its rotational period are the same length of time. And that means that 1 day and 1 year on Europa are exactly the same amount of time. Which is, that I feel is unique to the this moon. And here is just a comparison chart comparing our moon, Europa, and Earth. As you can notice, Europa and our moon are very similar in size, with Europa's diameter being 1,900 miles, like I said earlier. The moon's diameter is relatively close to that at 2,160 miles, and then Earth has a diameter of 7,917 miles. Alright, and it's a very young surface. In universal terms, it's only 80 to 120 million years old. It's the smoothest surface in our solar system, and it's composed of magnesium sulfate and sulfuric acid hydrate. And the magnesium sulfate is, if you remember, those brown streaks on its surface. That's what those are. And it is believed that the crust is frozen water, so ice covering a liquid ocean, which is a big deal. Not only the presence of water, but liquid. That means that there's a possibility of life, which would be really cool. And here are the two basic primary proposals. So as you can see here, the two cores, it has a metallic core like Earth's, composed of iron and nickel. However, unlike Earth, it is solid, not molten. And then in the first one, we can see the first